All right, you guys, what we're going to be learning today are what are called shorthand, or sometimes they're called noble gas electron configurations. And really what they do is they make this process of writing electron configurations, which you guys probably found, is kind of long. For some of those, atoms with a lot of electrons, that electron configuration can get really, really long. And so shorthand configurations shorten that up. And really what they do is they only show the electrons that are really going to participate in bonding, which is our next chapter. So it's kind of a preview of that. But I'm just going to teach you the method for writing what's called a shorthand configuration. Now notice the term noble gases in here. And you may or may not remember, if we go back to the periodic table, where the noble gases are in the periodic table. So noble gases are over here. And I know for the purpose of electron configurations, we've been moving helium. When we write a shorthand configuration, you can use helium as part of it as opposed to moving it over. And I'll show you that with some of the configurations we do today. But just a reminder, these are the noble gas configurations or noble gases. And to write a noble gas configuration, you use these noble gases to shorten up your configuration. So let me give you just the first example. Let's use nitrogen. We've written the configuration before. Here's nitrogen. It was 1s2, 2s2, 2p3. This isn't going to really shorten it up that much. I'm just going to tell you. What you do for a noble gas configuration is you find the noble gas, the element over here, that is in the row above it. So in this case, it would be helium because that's the row above nitrogen. And you're going to write it in brackets. And what that represents, it's not molarity of, like from the solutions chapter, but those brackets represent those electrons that are in helium. So it represents the first 2 electrons. That's what that represents. It represents the 1s2 electrons that are in nitrogen. And you don't have to write the 1s2 part. Now, if that represents the first 2 electrons, I still have to finish my configuration. So after the helium, I would still write 2s2, 2p3. Okay, so that is what's called the shorthand or noble gas configuration for nitrogen. Now, if that didn't quite make sense to you, that's okay. This is another case where sometimes it takes a couple examples. Let's go ahead and do sodium down here. Okay, we've done that configuration a couple times. So what we do to write the noble gas configuration is we find the noble gas in the row above it. So sodium is in period 3. We're going to look in period 2 and find the noble gas. It's neon. Now this one's going to make a lot more sense. We write Ne in brackets. And again, what that represents, I'm just going to show you, you don't have to write this. This represents all of the electrons up to neon, the first 10 electrons. So this really represents 1s2, 2s2, 2p6. I don't have to write that because I wrote neon. But I do have to finish the configuration. So I have to write what would come after 2p6. Well, after 2p6 would be 3s1, and then I'm done. That is the shorthand configuration for sodium. Let's do it for gallium, number 31. Okay, so gallium's full configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. It's kind of long, right? Well, to write the shorthand configuration, again, we find the noble gas in the row above it, which would be argon, and we write Ar in brackets. And again, that represents everything up until 3p6. So this represents the first 18 electrons in argon, okay? I don't have to write that as part of my configuration. All I have to do is finish it. So after 3p6, I would finish it by writing 4s2, 3d10, and then 4p1. Now some of you would rearrange this and write it like this. Argon, 3d10, 4s2, 4p1. And really you wouldn't have to rearrange it. Some textbooks and colleges do and some don't, just so you guys are aware. But just be aware that they sometimes do that. Okay, let's do one more and then you can try some out of your packet and see if you can get them right. So the last one we're going to try is molybdenum, number 42. So you know that would be a long configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d4. So to write the shorthand configuration again, we find the noble gas, again, one in the purple column, in the row above it. So that would be krypton, and I'm going to write Kr in brackets, just like that. And now I just finished the configuration. So what would come after krypton? So after krypton, after 4p6 would come 5s2, 4d4, just like that. And again, some people would write this. Some people, when they're writing configurations, like to put the numbers back in order, and they would write it like this. Either one is acceptable. So give it a shot. Try some of the ones in your packet that are for what are called shorthand or noble gas configurations and see what you can do. Again, step 1, you find the noble gas in the row before it, and you write that noble gas in brackets. Step 2, you finish the configuration, okay? You finish the configuration, you do whatever comes after that noble gas to get to your element, and you're done. Good luck.